Hi everyone and welcome to another video. In today's video we are still talking about the concept of independent events. In fact, we are going to be solving another type of question. If you remember, in our last video we actually solved a question relative to independent events about the experiment of picking some number of balls from a bag containing a larger number of balls. In today's video we are going to be solving questions about the experiment of rolling two fair die at the same time. If you want to check out the last video, I will be linking a video in the top right corner so you can just go check that out. Without further ado, let's start solving questions. So we have like 3 questions right here and we are going to be going over them one at a time. So the first question says two fair die, one colored white and one color red, are thrown. So we're supposed to find the probability that A, the score on the red die is actually 2 and the score on the white die is actually 5. And the second question says that the score on the white die is 1 and on the red die we have an even number. So our question says we have 2 die right here. We have the white die and we have the red die, but because I'm working on the whiteboard and then I'm having a black marker, I will assume my white die to be black and the second die is going to be red. So we have the white die, so this is the white die right here, and the sample space is going to be 1, we have 2, we have 3, we have 4, we have 5, and we have 6. So for our red die, the outcome is going to be, we have this to be red die. So the sample space is going to be 1, we have 2, we have 3, we have 4, we have 5, and we have 6. So the first question under the question 1 says that the score on the red die is actually equals to 2 and the score on the white die is actually equals to 5. So the outcomes that come out from the red die does not affect the outcome that comes out from the white die, or the outcome that comes out from the white die does not in any chance affect the outcome that comes out from the red die. So definitely the event of getting a value on the white die and the event of getting a value on the red die are actually independent on each other. So the probability of getting a 2 on the red die is going to be, probability of getting a 2 on the red die is going to be equal to the number of 2s we have on the red die divided by the total number of sample space. As you can see, we have just 1 2 on the red die, so that's going to be 1 divided by, and the total sample space is equals to 6. So that means the probability of having a 2 on the red die is going to be equals to 1/6, and on the white die the probability of having a 5, and on the white die probability of having a 5 is just the number of 5s we have in the outcome of the experiment divided by the sample space. So as you can see, we have just 1 5, so that's 1 divided by, and the total sample space is equals to 6. So the probability of having a score of 2 on the red die and a score of 5 on the white die is going to be equals to, so probability of having we have 2 and a 5 is going to be equals to 1/6 times 1/6. Please remember that the law is that probability of A and B is equals to probability of A times probability of B. So the answer to our question is actually equals to 1/36. So the probability of having a score on the red die to be equals to 2 and the score on the white die as 5 is equals to 1/36. So the question B says that the score on the white die is 1 and the red die is even. So let's do that also. So for our white die, probability of having a 1 is equals to the number of 1 that we have, so we can just write this as A and this is question B. So the probability of having a 1 on the white side is going to be equals to 1 divided by 6, and probability of having an even number on the red die. So how many even numbers do we have when a red die is being thrown? We have 2, we have 4, and we have 6. So that means probability of having even number, so that's probability of having an even number is going to be equals to the number of even numbers divided by the sample space of the experiment, and that is going to be equals to 3 divided by 6, which gives us 1 divided by 2. So the probability of having a 1 on the white die and an even number, so we have this, on the red die is going to be equals to 1/6 times 1/2, and that gives us 1/12. So the next question is question 2, and it says that you roll a fair die twice. What is the probability of rolling a 3 on the first roll and even number on the second roll? So let's take this upwards a bit. So what is the probability of rolling a 3 on the first roll and an even number on the second roll? So on the first roll, The sample space of the experiment is still the same. We have 1, we have 2, we have 3, we have 4, we have 5, and we have 6. And at the second row, the outcome still remains the same. We have 1, we have 2, we have 3, we have 4, we have 5, and we have 6. So the question says, what is the probability of rolling a 3 on the first row? So the probability of getting a 3 is equal to the number of 3 we have in the experiment divided by the total number of sample space, and that's going to be equals to 1 divided by 6. And the probability of having an even number is going to be equal to the number of even numbers divided by the sample space, and that's going to be equal to 3 divided by 6, which is equal to 1 over 2. So the probability of having a 3 and an even number is actually going to be equal to 1 over 6 times 1 over 2, and that gives us 1 divided by 12. So the last question says that, so we can call this question 2. So the last question says that if a die is thrown twice, find the probability of getting 2 5s. So we can say the third question, which is question 3, is that, so for the first row, we have the sample space to be equals to 1, we have 2, we have 3, we have 4, we have 5, and we have 6. And for our second row, we have 1, we have 2, we have 3, we have 4, we have 5, and we have 6. Probability of getting a 5 in the first row is going to be equal to the number of 5 divided by the sample space of the experiment, and that is 1 divided by 5. That is 1 divided by 6. And probability of getting 5 in the second row is also equal to 1 divided by 6. So probability of having a 5 and a 5 is going to be equal to 1 over 6 times 1 over 6, and that gives us 1 divided by 36. So if 2 fair die are thrown at the same time, so the probability of getting 2 5s is going to be equal to 1 over 36. I hope you learned something new from this video. Thanks for making it to the end, and we'll see you in the next one. Have a good day.